So for this week, all right, for this week, or for today's class, we'll be looking at functions and models. And I made mention of functions, and I said that that when we go forward, we'll talk about functions properly. So in this particular class, that's what we are going to look at functions properly. What are functions? What do they do? How do we use them? And before now, we've been using some inbuilt functions such as input function. We also use print functions and the rest of them. So in today's class, we'll see how we can also create our own function, understand what it is, how to create them, and how we can actually use them in our code. So these are the outlines. And so what exactly is function? What exactly is function? So before now, we've used the print function. We've also used the input function. So what exactly are these things? So um, in the simplest terms, functions are basically collections of instructions that solve a specific task, right? So mean that at some point your function should have a collection of instructions, right? And at the end of it, it should do what? It should solve a certain task. That's basically what function is. Take print function, for instance. Print function has lines of instruction behind it, and then its 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 own solution, right, is to solve the problem of displaying information to the user. Same thing happens with our own functions here. Exactly. So I think someone else has also dropped a definition of it on the group on the comment section, that it's a block of code that can be executed repeatedly with different inputs. Fantastic. So we're going to see how we can create ours, and we're going to see how we can use it specifically in Python programming. So function is not only available in Python programming, but it's also available in other programming language. And we're going to see how we can do that in Python. So these are like basically notes, right? And we look at them in our spare time because we're about 15 minutes behind time. Okay, so let's see how we can create these functions, and then we explain as we write the code. I think the code makes a lot of sense. Right, so as usual, I will go to my official folder for our project, which in my case, my own folder in my case is a desktop, and I have mine there. So these are all the code that we've written so far. So I'll simply just open up this folder in VS Code. So you can simply just go to yours and just right click. And if you have the option of opening with VS Code, you can just simply open there with VS Code. For me, I don't have that option, but I can actually open mine from my command prompt. So I'll simply just say cd into that directory and then open it in my code by simply typing code. And that actually gets open in VS Code. So this was where we were, or this was where we stopped in our last class. So we just continue from there. So in today's class, I'll simply just create a new file, and I'll call this file. This should be class. Sorry, this should be class 5, as in dot .py, class 5.py, class 5.py. So let's look at the definition of function again. Let me copy that from our slide for reference sake. So we said that that to create a function, we use a keyword def. And so let me just copy this for reference sake. I'll copy that and bring it to VS Code. So I'll comment on all of this. All right. So to actually create a function, right? So the whole concept behind function is this, right? The whole concept behind function is this. Now let's assume that we have specific codes, right? Specific set of instructions that we are likely going to be using repeatedly in our code. Then instead of repeating that code over and over again, all over our source code, right? We can simply wrap it up in a function, see function as a container, right? that we can wrap up these instructions and just save it, put it somewhere in our code, and then use it whenever we see need to use it. Now let's assume that I have this in lines of instructions. Say I have an instruction that says print hello world, okay, and I have another instructions that says hello codecamp, codecamp, and I have another instruction that says hello Python fast API beginners. All right. All right. Now, assuming these are my set of instructions, right? Your set of instructions can be complicated than this, right? But let's assume this to be a, a sample instruction, right? And let's say I intend to use this instruction exactly the way it is repeatedly in my code. Let's say at some point I can use it there, right? And then down the line, I can have other set of instructions. Say A equals 10, B equals 20, and C could be equals to what? C could be equals to, let's say, A plus B, right? These are like other instructions, right? That we may have. And I also still need to make use of this code again, the way it is like those three instructions. Now I could simply just come here and copy it, right? Copy it and come down here and paste it there and still use it, right? Now, I could also have other instructions, say if condition that says if A is greater than, let's say, 5, say print A is greater than 5, right? And then I also need to actually use this set of instructions again. So it means I have to come back again and do what, copy it again, and do what, and use it somewhere there again. Now you see that it makes our code messy, right? It doesn't actually make the code neat, right? Now this actually makes sense just because it's 3 lines of code, right? Assuming you have bunch of instructions, say about 1,000 lines of code, right? 1,000 lines of instructions, and then you intend to use those 1,000 lines of instructions over and over and over again at some point in your code, right? Not as if they're in a loop, but then there are some parts in your instruction that you need to do to use that exact 1,000 lines of code, and then you have to then go and copy it again. So imagine 1,000 lines of code being pasted here over and over again. Right? So you said that it will make our code cumbersome, right? So that is where function now comes in. Python now says, okay, if you have a specific set of instructions that you feel or you intend to 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 use over and over again in your project, all right, that you can pack all of them or you can wrap all of them in a function. And that's where that definition now comes in, that a function what is a collection of instructions that solve a specific task, right? So that's because at the end of it, this thing here should probably accomplish the task of doing of greeting hello world, hello CodeCamp, and hello Python fast API beginners. Probably that was the purpose of those instructions, right? Now, instead of doing this, of repeating this over and over and over, I'm likely going to be over and over again, we can do what? We can simply use one of it, right? Instead of repeating this, I can delete that off and delete it off. And then carry all of them and wrap it in a code block, right? And that becomes what? An instruction for a function. So how do we actually create this function? To create function in Python, we use the keyword def. So the keyword def, that is how you initiate, or that's how you instantiate a function, right? Now, once Python sees def, it automatically knows that you are about to do what? To create a collection of instructions that you can likely use in your project, right? Now, what you expect after your def is your function name, like what we have here, right? Look at this the syntax there, followed by what your function name. Immediately after your def should be your function name. In this case, I could call it maybe greetings, assuming greetings, right? And then what follows again is parentheses, that, and then you come back to the optional arguments. For now, let's leave that, since that is optional, let's leave that as it is. So we leave the parentheses there and then colon. And then whatsoever we indent after that function will automatically be considered as part of the instructions for this function. Okay. So when I press that there, at this point, this is the only instruction for that function, right? Are we following? At this point, this is the only instruction for this function. So to make all of them the instructions for the function, we need to do what? We need to indent all of them in. So we need to actually indent all of them there. So once we've done this all of them there, those 3 lines of instructions now becomes what? A part of our functions body, right? So this is all of them here now becomes what? Our function body, which is what we have here, function body, or your collection of instruction for the function greetings. And that is that. So with that, you can simply be repeating this code at any point you want without doing what? Without rewriting all these instructions again. That is the whole concept of function. Question before we execute this code. Any question? Question? No question. No question.
No question for now from me.
Okay. All right, so let's go ahead and do what? And execute this code. So I'll execute it as usual. And then we have what? We have a is greater than 5. But then we say that what? That that these instructions never executed. But then what happened? This other one did execute, right? So that's because indeed 10 is greater than what? 5. So this is the only instruction that executed in this whole line of code. Now you may be wondering, why did our set of instruction not execute? So the way function works is that it doesn't actually execute itself except you force it to execute, or you invoke it, right? You invoke a function, or you execute it, or you call upon it, anyhow you want to put it, right? But then a function will only live in your source code and only execute when and only when you do what? You invoke that function. Similar to how the input and the print function works. If you do not bring in the print function here, say in your code somewhere here in your code can never automatically print on its own, right? So that means you have to bring it, you have to invoke it for it to do what? So that means you have to actually bring it for it to do what? To actually work. Same thing happens to here. Same thing happens with your custom function. So it will live in your source code like as it is and will never execute, even if you run this code. So in order for it to execute, you need to do what? You need to execute it, invoke it, call upon it, anyhow you want to put it, right? For it to do what? To actually execute those instructions. That now tells us that what we actually did here can be considered as function initialization, right? So that means for the function to work, there are more like there are 2 steps involved, right? The initialization and function invocation. So I'll call this invocation, or let's say function calling, anyhow you want to put it. So let's use small English, right? so we don't confuse the international. So function calling, right? So how do we call a function, right? How do we make a function to execute the given instruction? So to actually execute a function, we simply call it by its name, followed by parentheses. So we call it by its name, which is in this case greetings, followed by parentheses. And that you have done what? You have called your function. Now, if you execute this now, you have your instructions now executing. We have the hello world, the hello KodeCamp, and the hello fast API beginners, followed by what? By this other instruction. Right. So now if I still need to use it again, I can do what? Instead of copying this code again, instead of doing what, coming here to copy this whole code again, I'm pasting again. I can simply do what, just come here and call it again somewhere down here, and it will still work. And with that, you can see that your code is more arranged. So you can see that actually executed the first part, and then the condition now executes, followed by the second invocation. Is that okay? Question. Question. No question.
It's not a question.
All right, shoot.
The place you wrote if I wrote print A is greater than 5. If possibly I replace that print command there with the greetings, will there be any error there at all?
Where exactly? Where exactly? Sorry, please. I think I lost it somewhere. You said that if you replace what?
The place you wrote if A is greater than 5, print A is greater than 5. Yeah. So my question is, if now you miss if I clear that print A is greater than 5 and put greetings. And the within display.
Yes, it is. Of course, your function will still execute. So wherever you place it, as far as this connection is true, then the action to what is for you to do what, to execute your function. And if you run this should at least show what 3 times.
So meaning in some cases I can replace that print to the function now, the function command.
Like you mean if you go, yeah, yes, if the thing is, if you actually seen it, because the whole thing about function is that if you were intending, right, to put this code, say, as the action of this if here, right?
Yes.
If that was your intention to put that code there as there, right? Then you could do this and it will still work. But then this is more like you doing what, repeating yourself. So what you could do is you could just simply replace all of them with the greeting function. Since the greetings instructions is that same code, then it will still work for you.
Okay, sir. Thank you.
Yeah, so that's the beauty of function. You put your code once and use it anywhere in your code, anywhere at all, and it will do what, and it will exist. As far as your intention was to actually use those instructions in that function, then just call it by the function name, and you're good to go. All right. Any other question? Any other question? So the silence means no other question. Okay. So
I have questions, but
okay.
yeah, good evening, Mr. Savior. I have questions, but I just joined, so I don't want to drag us back. I hope to watch the video later and catch up on what I missed. Because I really don't understand. Yeah, I really understand this part I came to meet, calling up an invocation and all of that.
All right. All right. Okay, let's see. So we've used 30 minutes. All right, so let's go over function again for like 5 more minutes, please. All right, 5 more minutes, and let's go over function one more time. All right, please, the person that asked that question, please pay attention properly. All right, so I know that once you watch this recorded video, so it can actually help you understand properly. All right, so function is more like a concept, right? The ability to use your code at multiple places without actually repeating that code. I think that makes sense. Yes, that definition makes sense, right? So the ability, right, to actually use your code without actually repeating that code. So now we now say, assuming we intend to use this code at multiple points in our program, right? That there's a way we can use those three lines of instructions without actually repeating that 3 lines of instructions. That's where function comes in, right? Now functions allow you to do what? To pack all the lines of code you intend, right, to repeat into one container and then repeat it without actually repeating it. I don't know if that actually makes sense, right? So it allows you to do what? To repeat these instructions, these 3 lines of instructions without actually repeating the instructions itself. Are you making sense? So we will repeat these 3 lines of instructions without explicitly writing those 3 lines of instructions over and over again. That's what function. Okay, that's the whole concept of function. All right. So if you had no intention of repeating this code ever in your entire program, then there's no point of putting it in function. Just write it out once, right? But if you have the intention of repeating it over and over and over again, all right, then do what? Wrap those instructions in a container. Python calls that container function, and then use it wherever you want to use it. Now, how do we wrap these instructions in a container? Python now says that we can make use of a keyword called def, right? So once Python sees def, it knows that you're about to do what? To create a container that should do what? That should hold a specific set of instructions, right? Right? Now, once it sees def, it expects what? The container name. That's the function name, which in this case we call it what? Greeting. Which in this case we call it greeting. So the moment Python sees def, it expects the name, the container name, or the function name, right? Now, and then followed by parentheses, compulsory syntax. The parentheses must come immediately after the container name, and then followed by what? Colon. Similar to your for loop, your while loop, and your if statement, the colons are always there. Colon is more like a Python thing, right? For a specific concept, though. All right. Now, after that, when you indent that, like when you move to the next line, whatever set of instruction is being indented, following after that would be considered as the function body, right? So now, if I push this man out, if I push these people out, these people out, at that point, it means that this is the only instruction in that function, right? So that to make all of them the instructions in this function, we can do what? We can tap it in, and all of them becomes what? The function body, right? So at that point, when we execute this code, right, without all this, when we execute this code as it is, after wrapping this in the function, when we execute it, we tend to see that nothing happened except oh, sorry, there's an error there. The error is here. So for now, I'll pass. So we looked at pass in our previous class. It's just a simple keyword that allows you to do what? To keep certain things blank, right? Like here, which after a conditional statement, you must do what? You must provide the action. But for now, we can do what? Simply skip it. We pass keyword. So that also tells us that we cannot use pass as variable name, please. So please, when we start using these keywords, note that these keywords are reserved words. We can't use them in our variables or function names as well. So if I execute this now, we see that nothing happens, right? But then we've written lines of instruction, but nothing actually happened. Nothing actually executed. That was where we now said that in order to execute your function, that you need to actually call upon the function. So that means for your function to work, there are two steps actually involved, right? In the step where you create the function, and then the second step is the step where you call the function. So we now say that so for our function here to work, we can start calling it. So if I uncomment this, uncomment this, uncomment that. So those things there is the same thing as me doing what? Copying this code, right? Pasting it there, pasting it here as well, pasting it down here as well. That's what it means, right? But with those invocations, we can simply use those instructions without explicitly reading or writing them out again. Now, if you run this again, then that should actually execute as expected. So it executed 3 times. That's because we called upon it 3 times. 1, 2, and then the last time. Is that okay? Question?
Sorry, sir. Please explain the pass.
So I think I lost you there, sir. Please come again. Question?
Okay, the function of the pass network kick
So I can't hear you properly.
me out of the meeting. So I missed this. The pass. When you initiated a pass, network kicked me out. So I up to you then.
All right. So please ask me the question, please. I think I don't know. I'm losing you.
It's Gaius, sir.
Okay, please, Mr. Gaius, please ask the question again.
All right. I've been following the entire class up to now. I understood everything, but not too long ago, network kicked me out. So when you added this pass to that particular block of code, I don't really understand the function of it.
All right. So this pass, all right. So this pass, I actually used it when I had nothing here. All right. So this by default, once you construct a conditional statement like that, Python will not allow you to leave it blank. You must provide an action. So in our last class, we said that in a situation where we need to go and come back and provide the action, maybe some other time or maybe let's go somewhere first and come back then do the action. Then you can alert Python, because if you execute this now, Python will tell you that it expected what an indented block immediately after what the if statement. So you go see the error there. Let me pull this up again. Let me pull this up. So you will see the error that says that Python is expecting what an indented block after the if. So by default, Python won't let you leave your if statements blank without the action. So we now say that there is a keyword that Python will actually obey, or will permit you to skip those things for now, and that keyword is pass. That's why I use pass there, so that we can actually execute this code without providing what the action. So the pass does not only work with if, it works with function, and in fact everything that needs indenting, the pass works with it. Your if statement, your for loop, your while loop, your function itself. So if I excuse me, if I should remove these instructions and then try to execute this, you have the same error saying that what an expected block was there was an indented block was expected after function definition, right? So and that I can still use my pass there, and that will still work, right? That will still work. So that was why I used pass there, right? That was the reason why I
understand.
All right. But for now, since we have the action now, I can now simply remove the pass and just put the action as if a is greater than 5, go ahead and do and execute our function. So that's now our action for that. Any other question? I think I'm seeing 2 hands are raised. Josephine, who's there? I think that was the first hand I saw. Meet and ask the question, please. Is Josephine still with us?
Yes, I am.
All right, what's the question?
I'm asking how to undo an error. Like when you type that thing, that pass, it's showing me syntax error file something. I want to undo the error. Is there a way to do that?
Wait, let me understand you. When you typed in pass here, it gave you an error.
Yes, like it showed me an error. Even when I typed greetings, print hello world, print hello camp, and then I added if a greater than 5, print a is greater than 5. When I ran the something, it showed me, it brought out hello world and hello camp KodeCamp, but that last one, if a is greater than 5, it showed error.
If a greater than 5, it showed error. Please
error.
confirm. Okay, can you read the error for us?
The error.
Yes.
Saying file pi shell line 4 in greetings. That's what it's showing here.
Right, so the error should be the last message. It should be your last message on your in your terminal. So if you execute this again, the error should be your last thing somewhere here.
Yes, yes.
Where it will show you the type of the error, and then the error say, please confirm that last line, and let's no.
Okay, said name error.
Name error. Greeting is not defined. Exactly. Greeting is not defined. Fantastic. All right. So similar to your variable names, function names are case sensitive. Please confirm that your greetings is the same greeting that they're using here. If you're using capital G here, please use capital G in all of them. Function names are case sensitive, similar to variable names.
Okay.
Right. Please confirm that actually works. Mr. I want to assume that Mr. Duncan, that Duncan is a Mr. Duncan, please go ahead and ask a question.
Please, I wanted to ask, how do you add the hash sign to your lines of code simultaneously? Like, if there's something that you do and the hash sign will just appear. Yeah.
Okay, all right. All right, so to actually do that, you simply highlight the lines of code you wish to comment. So in this case, assuming I wish to comment all these lines of code, so I highlight all of them, and then I do Control plus / and it will comment on all those lines. So that command works for VS Code, right? So I'm not sure if it works on other text editor. That actually works on VS Code. Right. So please also make sure that you're using VS Code as well. So that can actually work for you.
Yes, I am. I'm using VS Code.
All right. So please go ahead and highlight and do Control / is this. This is /. Let me put it up there.
Yes, I know what the / is.
All right, sir. All right, sir.
Okay,
any other?
I have tried it. It has worked.
Okay, perfect.
Thank you, sir.
All right. So any other question? No other question. So we can proceed with function. All right, fantastic. All right, so let's go back to our slide and let's see what we have there again. So we also have function arguments. Question? Right, so we also have what we call function arguments. All right. Don't worry, I will just slide will come. We'll just wait through those notes. Slide will come. All right, so function arguments. So what exactly is function arguments? They are basically a way your external instructions communicate with your function. Let's assume that we have another function, right? Let's assume that we have another function. Say this function is called addition function, right? Oh, sorry, addition function. And of course, this should go with that. And then this function should be able to carry out an addition of A plus B. I don't know what A plus B is. A plus B can be anything. For now, we don't know what A plus B is. And it should print the result of A plus B. So in this case, I will assign this, this expression to a variable called result. All right. Let's assume that your function was supposed to do that. Right. Let's assume your function was supposed to do that. But then the value of A and B is supposed to come from somewhere outside this function. All right. Somewhere outside that function. Now we need to send in the value of A and B to your function. And to do that, we make use of function argument. So function argument is basically a way we do what we send data from your external function code to your internal function code. Are we making sense? Is that okay? Should I set up again?
Yes, please do. Can you just explain it again? So I'll just grab it again. Thank you.
Okay. So I'm saying that function argument, right, is basically a way we do what we communicate with our function. Right. So I'm now saying that assuming we have another function called addition function, right? And then this function, right, is supposed to carry out an addition of two numbers. say that number can be called A and B, right? Assuming, right, that those numbers can be seen or can be known as A and B. And then this value we don't know. We have absolutely no idea what this value could be. Now, but then we want this value to be sent to our function, and then for this addition to be carried out. Now, the way or the method which we can actually send that value is through function argument. So I'm not saying that function argument is a way we do what we send data or information from our external function code to the function body itself. Shall I say that again? So our external function code are basically this code outside of our function. Those are external body function codes, right? And then we do what we send this external information into our body, into our function body. And we can do that using what function argument. Should I say that again?
So if I'm to understand you,
okay,
it's not external functional, but it is any other variable that is outside this very function that we want to act on now.
Please come again.
Like,
please come again. All right.
What we want to effect now, it is not, you said external function.
External function code, yes.
Any other external variable, anything that is outside the function.
Okay. Exactly. So now we want to do what we want to send information that is not even part of the function body, and then send it into the function itself. And that can be done using arguments.
Okay, I understand.
All right. Any other person that is having difficulty with that? Should I say that again? Anybody? The silence means nobody. All right. So let's look at the types of arguments we have. So we have three major kinds of arguments, right? We have positional, we have keyword, we have default. I'm going to say how we can implement all of this. So I'll start with the positional argument. So I will clean this up for now. I will clean this up for now. And I'll have just that. Just that for now. I'll have just that. Okay. So now let's assume that let's start with positional. Positional argument. Okay. All right. Now this is our function here, right? And then we need to do what? We need to pass certain information to this function. We can do that, right, by specifying list of variables in the function parenthesis, and where each of the variable represent a specific data or information. What do I mean? Let's assume that I am expecting to carry out the result, the addition of what of A and what and B. Meaning that I am expecting two information, two values, right? Two values to come into this my function. So in that case, what do? I can simply go to my function, the function parenthesis, which is here, right? And do what? And provide two variables for those two values. The variables can be of anything. It can be A, B. It can also be W, anyhow, right? It can be num1, num2. It can as well be var anything. As far as it's a variable, it's a valid variable name, then it can do what? It can actually stand. So with that, I'm simply telling my function, right? Or I'm simply letting Python know that this function must expect two values. So now I've done what? I have created room, or I've created passage for two values. So this function cannot take one value, and it can also take more than two values. It must take two values, right? So now I can do with that I can do send external data to the function, and the function and the function can do what? Can simply use it and do whatever it needs to do what to do. So for a start, all right, for a start, I would simply say, all right, let us do what? Let us display these values. Let's be sure that these values has been sent to the function body. So I'll simply just say print var1 and also say print var2. Right. So var1 and var2 happens to be what? The variable that we specified as passage for this function to what? To accept two values. Right? Two values. For now, those values can be of any type. Excuse me, those values can be of what? Of any type. Because we're simply saying that this function must carry what? Two values. Right? And Python has absolutely no control, or sorry, it has a control, but for now it has no control of what kind of value is coming. But then it knows that in order to use this function, two values must be provided. Right? So going back again, I will assume that I have a variable here outside my function. I can call this variable 1, and I say variable 1 is equals to, let's say, 10. I can also call this one variable 2. I can say variable 2 is equals to, let's say, 30. Now let's assume I want to send these values into our function. That I want our addition function to have access to what? To these values. Now to do that, I can simply pass this value as the expected value of this function. And to pass that value, we pass it during function invocation. So it simply means that we cannot use this function without providing what? A mandatory what? Two values. So if I try to come back again and then I say addition, and then I want to just invoke it as we did, right? And then I execute this. It says what? That addition, being what? A function, is missing what? Is missing two required positional arguments called value1 and value2. So that if you must provide at least two values. So for now, I can say, okay, let var1 and var2 be the required what? Values. And if we execute this again, you see that our function, right, has now have the access what? To those values. So we could say that we printed what? The value1 and value2, which is exactly what this value is there. Now these values can be of any type. It can be of any type. So it can be hard-coded itself. It means that I can still come to that function and do and still type the value inside here, right? Let's say I want to pass save as well as part of the value, and then I can execute this, and this will still work. And what? And a value1 would be seen as what? As savior, and value2 would be seen as what? As 30. So that's where the name. That's where
okay. I have a little question now.
All right.
Basically, now,
Okay.
you said it should print val1, which is value1,
Okay.
and print value2. But you did not really relate variable 1, which is var1, to that value. So I didn't know that is to pick
Okay.
var1
All
and
right.
up to.
Okay. That's fine. That's what I was about to explain. That the name positional, that the way it actually behaves is based on the position of which we provide this information. That is why it's called positional argument. So here we have value1 and value2. It means that whatever value you provide the first as first argument would automatically be considered as value1. So in this case, savior was being provided as a first argument. So it automatically knows that savior should be what? Value1. Same thing with what? With var2. That is where his name came from, positional argument. So it uses the position to do what? To identify them. Is that okay?
Okay, I get it now.
Any other question? Any other question? The silence means no other question.
There's
All right.
question now, sorry.
Okay.
You say it uses the position. Is it the position of val1 or variable 1?
Okay. All right. So it uses the position of the values provided. So this is my function here, right? And I said that this function will take two values, and we assume those two values to be what? val1 and val2. We assume it within our function. That the first value should be seen as val1, the second value should be seen as what? As val2. Now, when you're invoking this function, depending on how you provide the values, it will be seen accordingly. Meaning that if I invoke this function and I provide savior as the first argument, as the first value, it automatically sees savior as val1. Now, if I provide variable 2, which in this case is what is 30, so it will automatically know that variable 2 is what is 30. That value 2 is what is 30. If I exchange this, probably this bar 2 and bar 1 is conditional. All right, so let's just change this, or probably let's hard code this. Let's just hard code this. Now, if I provide 10 here, right, it automatically assumes that val 1 should be what? The first argument being what? Savior, and val 2 should be the second argument called 10, right? Now, if I do it again, if I invoke again, say addition again, and then I provide another value, say KodeCamp, right? Now, KodeCamp will automatically be considered as what? As the first value. And then if I come here and provide 4.0, 4.0 will be automatically be considered as what? As val 2. If I exchange this, if I bring this man, if I carry 4.2, sorry, 4.0, and place it before KodeCamp, and leave it like as it is, then val 1 will be automatically be what? 4.0, and val 2 then will be what? KodeCamp. So it uses their position, right, to identify them. Is that okay?
Yes. Yes.
All right. So any other question? Any other question? All right. So the fantastic thing about function arguments is that we can provide as many values as we want, dynamic values to our function. Right. So we can provide dynamic values. Like now, I invoke the first addition with a separate value. I can still invoke the second one with a different value. So that's the beauty of function arguments. We can pass in dynamic values, right? So not because I invoke this one with 7 and 10, it does not mean that when I want to invoke again, that I must still use what? 7 and 10. I can use any other value, right? I can use any other value, and the function will process it accordingly. Is that okay? So far now, right? If I invoke this function, this will actually work as expected. So we have the first invocation, 7 and 10. We have the second one, 4.0 and KodeCamp. So with this, I can simply just create a simple addition function. Say I want this function to show, not to show val 1 and val 2, but instead let it be the addition, because at times, okay, it is recommended that you name your function according to the problem it intended to solve. So in this case, let's assume our function name is what is addition. So it means that it's going to add multiple values. So I can just simply say, go ahead and show the value of 1 plus the value of 2. And then if I invoke this will throw an error, because what? Value 1 being what? Savior cannot add what with 10 being what? An integer, right? So as such, I need to provide numerical values. So I could say 10.7, yeah, or 10.8 as value 1. And I could still come back here and provide another addition, probably 5 plus, let's say 5, right? And this will still carry out calculation as expected. So we have 20.8 and we have 10 as expected. Is that understood? Question? No question?
Please show the answer again.
All right.
Yeah, show the answer again.
Okay. So, you know, we have 10.8 and 10 there, so that should be 20.8. So we have 20.8 and 10 as well. So we invoke our function twice, which is here and here with separate values. So that is that there. Right. So your function can as well carry as many arguments as possible. So even if you had the intention of passing 100 values to your function, please provide 100 variables in the function parenthesis. And then when invoking, also do what? Provide 100 values to be sent to the function. To be sent to the function. That's how it works. All right. Any question before we move to positional? Sorry, before we move to keyword. Any question? No question. No question.
Please, good evening. I have a question.
All right, please.
Sorry, my name is Shedrack. Yeah. So, my question here is that so the number of values you are passing into the parentheses must not is not restricted to 2.
No, it's not restricted.
Okay,
so you can have from zero to infinity.
Okay.
Yes.
Okay.
Yes, so it's not restricted to 2. So if I come here and add 3 again, if I come here and add comma bar 3, then it will tell me that this man here is missing one more value. So if I run this, it says that addition is missing one required positional argument called bar 3. So that means I have to go back and provide 3 values here. So if I come here and I provide 100, come here and I provide another 5, then they should do the math. Oh, sorry, this should be comma, not dot. Comma. And then we run it here again. So we still have the same result. That's because we only added bar 1 and bar 2. So if I go back to our function and say, go ahead and add bar 3, then that should add the full addition of those 3 values. So we have 120.8 and what? 15. So you can add as many as you want, or you can have an empty function like this without any argument. Is that understood?
I have a question.
All right, apps, shoot the question.
Please, I'm using ideal shell. I don't know if, yes, ideal shell. Is this the right platform for me to be using, or is it different from VS Code?
IDL
yes,
actually comes with Python installation. I believe this what you're actually using.
Yes.
All right. So well, we can use this, but then we use this in our first class. Were you there in our first class?
No, I was not.
Okay. All right. So we use this in our first class, and we said that the way shell works, shell automatically executes your instruction immediately. So you can actually use VS Code.
I have 2 children. The span of 5 minutes. The span of 5 minutes.
All right. So we use this in our first class, and then we said that that we won't be using this due to some other interesting features that VS Code offered us. So this one here is quite basic, right? And it's quite basic, and then there's not much feature here. But then if you are still using this, right, then you want to create a new file, and then this is where you put all your code in a new file, right? And then so you want to copy all this file here, right, and put it in a new file. and then
Okay.
you do what? You save this file, and then you click on run. Once you click run, it will require that you save the file,
Okay.
right? And then you can give your file a name, or you can choose a directory, which in this case you can choose KodeCamp 4 beginner folder, like we've been using here, and then you can call yours your own class, probably class 5 as well, right? And then you click on run. So in this case, I'll call mine a name that has no meaning, some gibberish there, right? And then I save, and then it does execute there. All right, so
Okay.
don't type your code here in the shell, because if you type your code here in the shell, it will execute that code the moment you click on it or enter. So it won't give you room to do what, to write out all your codes. So the moment you click on enter, it executes that code instantly. And so the shell is only used to do what, to test a small portion of our code.
Okay.
Right? It's used for testing, right? So you wouldn't want to write your full code here, your project here, right? So
So what it means is that I have to install VS Code.
Most recommended. You can install VS Code and use it. But for this class, since you now have VS Code, please create a new file like I've done, and then you can type your code there, and it will still work.
Okay, thank you.
All right.
Thank you, sir.
All right. See, I think I saw someone hand raised. Mr. Duncan.
Yes, sir.
All right, please ask.
Please, I was trying out that keyboard combination, control plus the forward slash.
No, don't add plus. Just do control slash.
Yes,
the plus that means that you just join them together.
Yes, I know. Then I don't know what I pressed on my keyboard, and my VS Code started to like duplicate. And yeah, I sent the screenshot on the chat. I don't know how to fix that. I'm so confused right now. My VS Code was duplicating, and I don't know what to do.
Fantastic. Okay. So close them one after the other, then, or you close them one after the other.
Okay, sir. Let me try that.
Yes, close them one after the other. All right. So while Mr. Duncan is closing his VS Code one after the other, we can continue.
Yeah.
Oh, sorry, sorry, I shut you off, Mr. Duncan. Please, any other question? Please unmute and continue, please. I think I shut you off by mistake.
I said it's working. Thank you.
Okay. That's fine.
Sorry, quickly, sir.
Okay.
In the other, when you started initially, when
Okay.
you define variable 1 as 10 and variable 2 as 30,
Okay.
it wasn't under the block of code of the defined function. It was outside, right?
Yes, it was an external code. Yes.
Okay, thank you.
Outside.
Thank you.
Okay. All right. Any other question?
Please, sir, is it possible for you to just explain this concept again? Because I was not focusing. I was trying to fix that problem. Sorry, sir.
The problem of duplicated VS Code.
Yes, I was trying to fix it. I was not focusing. Sorry, sir.
All right. For the sake of Duncan, let's recap what we just did. 5 minutes, right? So we said that Python has provided a way we can do what we can communicate with our function, where our external code can communicate with the function itself, right? So we can send values from outside the function to inside of the function using what argument. And then we said that arguments are basically placeholders in the function parentheses. They're like placeholders that stays in the function parentheses, right? They are placeholders that stay in the function parentheses that signify that this function is expecting certain what number of what values. And then if you look at our function here, right, we have what the additional function. Sorry, the additional function there. And then within this function parentheses, we have some placeholders, some variable names there, which in this case is what is value 1, value 2, and value 3, right? Now, once we do that, Python will automatically know that in order to make to invoke or to call on this function, that the user must, or the programmer must do what, must provide 3 values, right? 3 values. It could be of any type. It could be of, but as far as we have 3 values separated by what, by comma, we are good to go. And then what happens is that Python will automatically jump that value and then make that value to what, to be accessible inside of your function, like what we've just done here. So that means if I come inside my function and then I say print var1, I can access the first value that was provided during function invocation. If I also say, excuse me, if I also say print var2, I can do what, I can access the second value that was provided during what function invocation. Same thing happens with var3. So that's the trick there, right? So Python will allow you to do what, to create placeholders, all right? Variable that have what, that are placeholders that are signifying a specific value, or variables that are signifying any values that at all. Which in this case, this var1 is representing what, a value that will be provided. Same thing with var2 and var3. So when we do that, then during invocation, we must do what, we must provide those 3 values. Now, the order in which we provide it also matches the order in which it was done, it was defined in the function. So here we say that we want to provide 8.10 as value 1, 10, and then 100. So since we arrange this as var1, var2, var3, it will automatically also match them like that as var1, var2, and var3. So what happens then is that when we invoke it now, this value is what is being sent, or this value is being made available or accessible to our function body. So it means that within our function, we can know what we can access these values here within our function, and which is what we just did by simply adding up all of them and showing the result. Now, if we execute this, we can now say that that var1, var2, var3 will access what 10.8, 10, and 100, and they will carry all of them, add it together, and show you the result, which was what the function body. All right. It doesn't mean that their function must always do that. In this sample, our function is doing that. Okay. Now, if I execute this, then that should work as expected. So we have 120.8 and 15 there, because the second invocation we did 5, 5, 5, meaning 5 plus 5 plus 5 in this case here, in this instruction here, right? Is that understood?
Yes, sir.
All right. Is there anyone that's
Please, I have a question. I have a question, sir.
All right, please ask a question.
What if you decide to pass in an argument, sort of like in this argument in that function,
okay,
is not defined maybe as integer or as boolean or something. So what if you decide to pass in a string here now?
Okay.
And then instruct it to string.
Okay, so let's say I pass in a string of 100.
Everything inside you pass, you just
okay.
Yes, you turn it to a string. What will happen?
So what will happen is that since everything is inside a string, it will carry out what we call string concatenation, which we will talk about when we get to string. So if I run this will still execute, but then this will show us as 10.8101000. So this is what will actually show. 10.8101000. That's what we call string concatenation. But in a situation where we probably we have at least one integer or one numeric value, then this will break our code, because that addition will not happen. So you see that that's unsupported type operand, right? So we have a float. I was trying to do add a float with a string, so that cannot happen. In this case, we can now come here to start to start writing checks to check if that we only want to add this thing if they type. Remember this type function that we use. That if the type of val1, right, is integer, is int, and same thing with val2, val3. Then that's the only time, and that's the only time we want to do what to kind add the addition. So that's how you can actually prevent that. So if I copy this and put here now, and say and val2 is also int, and val3 is also int, then go ahead and do what? And add. So I'll tap this in. Now, if I try to execute this, you see that nothing will actually happen. This will our code will execute very well, but this will not add. Only this will add. See if you run that. So you see that well, seeing that let's see what's happening there. So the code didn't actually break, but this didn't add, and this didn't add as well. So let's see what is happening here. So none of it actually did execute itself. Confirm something first. Let's see that type val1. Let's confirm that. Let's comment this. Let's see.
Lisa, why is the int the integer in what's it called, a string format?
Okay, that's because int. All right, so we can't just leave the int there. Yeah, you're right, bro. That should work without a string. So sorry, this should be int, please. So if I execute this should now work as expected. So that actually works. So the thing here is that what we were trying to actually compare with was not actually a type of int. Like, so we're trying to actually compare with a string of int, right? Of course, the return value of that type is not actually a string, but then a type itself, a recognized type itself in Python. So you can just take all that and that will actually work. So if I put this back again, then you see that this will only execute the first one, the last invocation, which is 15. So that's how you can actually manage that error or that kind of situation. So you can actually cross-check that all of them are integer, then you can do an add, right? So in a situation of like this, you can now come and add the else by simply letting them know that that all arguments, okay, all arguments must be a valid integer in this case. So if you run that, then we should have the first one that's saying all arguments must be a valid, and then the second one that actually did the execution. Is that okay?
Yes, sir. Yes, sir.
Did I complicate things? Any question?
Yes, sir.
Please, let's ask question.
Yes, it's quite complicating. This
Yes,
last part.
confused, sir.
All right. So the question was, okay, the question that Mr. Duncan asked that brought about us to do all these things was that Mr. Duncan asked, right, notice that so far, because I mentioned it that Python will only provide space for those values, but then cannot, or it can, but then at the moment, you can pass in any value. You can pass in an integer, you can pass in float, you can pass in a string, right? It doesn't matter, it will still work, right? But then in a situation where our action for the function was to sum the value, all these three values, and then a user now comes and now probably come here and provide a string instead of an integer, right? What happens is that when we try to add all these things together, which was supposed to be the action of the function, that will throw an error, right? Because we have a data type that we cannot add with a numerical value. So if I tell you 10.8 plus savior, what will be the result? You say that we can't add that. So you're not asking how do we manage kind of that such situation. So I'm not saying that we have built-in data types, right? We have built-in data types. We have built-in strings. We have built-in int. So if you actually come outside here and then just type int, you see that int there is recognized, right? So it is actually a reserved word, right? So all those types are reserved words. We have int, we have bool, we have list, we have float. So all these are reserved types in all these are data types in Python. So I'm not saying that to solve that kind of situation where a user may mistakenly provide a string value instead of may provide a string value instead of an integer value, right? That we can do what that we can carry out a check using conditional statements. So before we add, we want to make sure that all the values provided here are all integer class. So we now check is the type. Remember, the type function returns what the data type for that value, right? We use this in our very first class, the type function. So we're not saying, well, if we can add the type of val1 and it's equals to and it belongs to the class of integer. Same thing with the type of val2 and it's the same thing and it belongs to the class of integer. Same with val3. Then go ahead and do what and add it. But for any reason we can add this validation and one of these value does not belong to the integer class, then we do not want to do what to add, because if we try to add it, it will break our function or it will break our code. So that's why we actually did that. That was the question that led us to carry out this validation checks. Is that okay?
Yes, sir.
All right. Any other question? All right, so the silence means no other question. All right. Okay, no problem. My own question is coming, don't worry. Okay. All right, so let's look at positional argument. All right, so I'll copy this, right? And keyword arguments. So keyword arguments are similar to propositional, right? Except that for keyword, during your Python invocation, we can explicitly, right, let Python know this value belongs to this argument, this value belongs to this argument. So how do we do that? We can now go back to our function invocation, and then we can now say, all right, that value 3 should be equals to this one. So in this case, I can come and say value 3 is equals to what? 10.8. So I explicitly assign values to those arguments. By doing such, that is what we know as what keyword argument. In that case, the position in which these values are actually arranged does not matter again, right? So I can now say, let this one now be my val1. So my val1 would be this one, right? And my val2 would be this. Val2 would be this one. So at this point, the arrangement, the arrangement no longer matter. So your 10.8, right? Your 10.8 would not be val1 again, but then it will be the value for val2. Savior it will now also be what the value for val1, and so on and so forth. So when we explicitly assign values to these variables, that is known as keyword argument. Is that okay? Is that okay?
Sir.
Yes.
Sorry, I'm taking you back to that.
Okay.
This place. When I typed in and I ran it, it's saying expected an indented block after function.
After function. That's because you've left your function blank. You've not given it a function body. So it's either you've actually done this, right? You've moved this man outside of the function, Right. So at that point, this does not have that function does not have a body. Right. So you have to make sure that you tap them in. You tap all of them in. Right. So that is the problem.
In.
They are in.
Yes.
Please send us a screenshot of your code. Let's see.
Okay.
In a chat session. All right. So while she is sending that, any question on keyword arguments? Any question on keyword arguments? Any question on keyword arguments? No question on keyword argument. All right, no problem. A question will come on keyword, and that's on that same keyword argument, question will come. All right, so let's look at default argument. Okay, default argument. So before now, I'll simply just copy this again. By now, we should be used to copy and paste by now. Right, so we've been done, we did that in our last class very often. So we should be comfortable copying and pasting.
Hello, sir. Good evening. I'm sorry. Can you hear me, sir?
I can hear you.
Okay, sorry. I think my network disconnected me, so I didn't really catch the keyword argument. I don't know if it would be okay for you to just go through it again, please. Thank you.
All right. All right.
Thank you, sir.
All right. So keyword argument, like I said, it's similar to a positional argument, right? Except that for keyword, we explicitly provide a value for the argument itself. So what do I mean? If you look at our positional arguments here, right? We provided three values: this value, that value, and that value, right? And then Python will automatically match them based on their position. Where this value here will be seen as what as your val1, and this value here will be seen as what as your val2, and this here will be seen as what as your val3. But in the case of keyword argument, we can explicitly say, I want my val1 to be this value. I want my val2 to be this value. I want my val3 to be this value, which is what we did here. So here we say that I want my val3. Remember, this name here must be the same name that you provide in your function definition. So I can't come here and say I will let A be this. This will turn an error. Once we execute this, Python will tell us that this man here is still missing a value. That val3 is missing a value. So the name must be the same. So I can now come here and now say that I want my val3 to be this 10.8, my val1 to be what, savior, and my val2 to be what, to be 100. In this case, the position or the arrangement of this argument does not matter again, right? So Python will now know, okay, that this value belongs to what, val1, this value belongs to what, val2, this value belongs to what, val3. Now the arrangement does not matter again. That's the difference. And the difference between what keyword and positional argument. Is that okay?
Yes, sir.
Right. So I didn't just provide the values like I did here. I explicitly assign the values to the arguments themselves. All right. All right. So we are still waiting for I think who was that? Miss is it Josephine? I'm still waiting for the screenshot, please. All right. So while that is coming, let's look at while that is coming, let's look at default argument, right? So unlike positional argument and keyword argument, default argument is more like providing a fallback argument, a fallback value for each argument. What do I mean? So let's look at this again. If I try to invoke this function, right, without providing the three necessary, sorry, there should be addition, without providing the three required arguments, what happens? If I try to execute this, what then shows? It shows that this man is missing what? Three required arguments. So as such, I must provide those values. It's a must. It's compulsory, right? But then we can do what we can provide a fallback value just in case a user fails to do what to provide those values. Then the function can do what can go ahead and work with those with the fallback values. And those fallback values is what we know as default argument or default value for the function, default function values. So how do we do that? We provide a default value during function definition. Please take note. Positional and keyword is being provided during function invocation. Default value is being provided during function initiation. So while you are initializing the function, you can only provide the default value in that function body, in that function initialization, right? Not during invocation. So I have to go back to my function and then do what? Assign a value to all these arguments. So in this case, I can come here and say, okay, fine, I want my val2. I want val1 to be what? To be 0. If a user does not provide value for what? For val1. Sorry, this should be 0. That's if a user does not provide value for what? For val1. Same thing with val2. Right? Same thing with val3. And those become what? Your default arguments. The default values. Now I can invoke this function. Let me comment on all of them there. I can invoke all of them. I can now invoke this function without providing what? Values. And that will still work. And we have what? And we have 0. That's because we've provided a default value. So what happens is that since we not actually provide a value, Python that what make use of what of this of this value there. Right? And then what happened? It just did what 0 plus 0 plus 0 being what? 0. Default value. Is that understood? Is that understood? Question? Me Josephine, we are waiting for your screenshot. Question? No question.
Hello, sir. I have a question.
All right.
Good evening. This is Precious.
All right.
What about in a scenario where I don't know the particular amount of arguments I want to pass, but I want to use just one function? Like for example, for this first calling, I want to add 3 numbers. The next one 4 numbers. Next one 5 numbers. So how will I do that?
Fantastic question. Fantastic question. Fantastic question. That is a very beautiful question. I was expecting that question. Pressure server, because that's the question our actors says we don't have the question. But pressure servers. All right. So how do we do that? It's all right. So we can do that. Okay. Let me create another function for that. Right. I'll call this other function multiplication. I'll call this multiplication. Right. And then, in order to provide an infinite room for variables, or should I say a dynamic room for variables, we can simply still provide a variable name. But this one, just provide one. Assuming I'll call this one. I'll call this one variable 1. Just one variable. Just one variable, right? And then the body would be, let's give it a body. Remember, Python won't let us pass without that body. So this one will simply just do what multiply everything that we have here. Okay. Let me just go ahead and show us the variable 1. Okay, how it will look like. So in this case, if you try to execute this right now without the variable, right, it will require what? One argument by 1, right? And then if I come back here and I provide 1, say I provide 10, and then I try to do what? To run this, it shows 10, right? Then if I go back again and say, let me add, let's say 20, and then I run this, it shows an error that this math only takes one positional argument, but we do about 2 were provided. So as such, we've provided more than. So in this case, we provided more values than what the function can do or can accommodate. So to make this to actually work in a dynamic way, where we can provide as many variables as we want, You simply go to that your variable and do and put asterisk in the front of that variable, asterisk there, and that problem is solved. And now it simply means that that variable 1 can contain as many variables as possible. It can contain 1, it can contain as many as possible, and it can contain 0. Right. Now, if I run this now, see, that did work. So that actually worked, right? So what happens is that it will wrap all those values in what in a tuple data structure. Don't worry, we'll talk about tuple in a future class, all right? So, but this is how it will wrap those values, right? It will wrap those values. So we can provide as many as one, all right? And that will still work. I can provide 30, I can provide 40, I can provide 50, and that will still accumulate all of them, right? That will still accumulate all of them. So that is how you will solve that. But now, by convention, you will not see this. This is what you will see out. Right? So you will always see that, and not any other variable. So it's just that in the Python community, we just have a way of doing things. Not that it will not work, it will work, but then let's just follow convention. Right? So by convention, you always see this kind of variable in a function. If we intended to have a dynamic function that can carry as many variables as possible, then you always say that the variable, that the parameter, the function argument will always be called args, right? So it's a short form for arguments. Is that okay? So you simply just put the asterisk in front of the argument, and it will create room, and Python will automatically know that function can contain as many variables as possible, as many values as possible. I mean, is that okay?
Sir, please. Yes, I've sent the screenshot. Please.
Yes, sir, it's okay.
Help me with that.
So let me check the screenshot now. Okay, yeah. All right. Let's see if we can zoom this in. So it says that an expected indented block after the function definition. All right. So if I'm looking at this clearly, it's exactly what I just said. Let's see, your if is outside is where your def is. So you should tap in that if. If you look at what my own if, there are about three indentations there, right? Sorry, 2 of it there. So if right, so we have this first indentation for the if, making sure that that if becomes what part of the function body, right? But then there's another indenting here, making sure that the print is become what the code block for the if statement still being what part of the function body. So if you look at your code, you can say that your if there is just immediately is on the same line with your definition. So you want to tap it in, and you're still working with shell. Please go to the new file and put your function there, please. Don't work with shell. Shell is just for testing, no, please. Don't work with shell. And then after the class, please download VS Code. Right? So we can all be on the same platform, or so that we can help ourselves quickly, right? So that's the bug there in your code. Please indent that in, and your code is good to go. All right. So any other question? Any other question? No other question. No other question. All right. Okay. The silence means no other question. All right. Let's look at what we have there again. So far we've been using our function, but yet the thing is that we can actually assign our function to a variable and then get a specific value from our function, right? So let me comment it out right again. Comment it out, all right, and then I will invoke this function again. Right, let me invoke this addition function again. Now let's assume that I intend to use the result of this addition, right, with other lines of code outside the function body, right? So now let's assume that we intend to use the results from our function in our external function, in our external lines of code, right? In our external function body code, right? So that means we can assign this function to a variable and do what and get its value, right? I don't know if you understand this concept. If I should assign this to a variable, let's say I call this a is equals to that function. If I should say print the value of a, I should get what? The result from that function, right? Being assigned to the variable called a. Let's assume that I want to get the 15 from that function and then use it in my code again, some other place in my code, right? Some other place in my external code, right? I can do this. I can simply assign this function to what? To a variable and get the value of it, right? That should work now, logically.
Logically, that should work, but can we try it just for experiment's sake?
All right. Okay, we will try that. Is there anybody that will not work logically? We've taken time now. Some people have gone to the and try it at first and come and tell us yes, it's work, no, it's not work. All right, so we logically that should work, right? That should work because we should always get a value from our function or a result from our function, because remember a function can actually do what? A function what is a collection of instructions that should solve a specific task, and optionally should do what? Should return a result. That is what the function should do, right? So this should work, right? See, but then if I execute this now, we have none as the value of this function. We have none as the value of this function. That 15 that we are seeing there is the print statement that is in this function. If I comment this man out, or if I remove this from the print function and say let this be equals to result, and say let this be result, without doing what? Printing it out. If I execute this function again, we have what? We have none as default value. So that happens automatically. By default, if we do not return a value, right, your function will return none as a value automatically. That one is Python's nature. We cannot control it, but we can work with it, right? So there's a popular saying that we can't control the wind, but we can adjust ourselves, right? We can't control that particular behavior, but we can do what we can work with. Like we can maneuver it to do what? To return another value or a desired what? A desired value, right? So how do we do this? Because even if we assign other functions to a variable, the default result or the default value of that function is none by default, right? Every function has a default value of being none. So now if I wanted this result, how do I get that result from our function? All right, so that is where this keyword comes in. This keyword is called the return, This keyword is called the return keyword, right? This keyword is called the return keyword, right? So once we use the return keyword, we don't, I believe this keyword works only inside a function. If you take this keyword outside your function, it does not work, right? So this man here, it works only inside the function, right? So once we use this statement inside the function, it will return that specific value and not the default value of none, right? It will return what? That specific value as the value of what, or as the result of what, of that function. So assuming I wanted this result, so what I can simply do is I can simply just come here and say, after adding it, don't just print it, give it as a return value. So I will simply say return, and then what am I returning? I can specify what I'm doing, I want to return. I can return any value there. I can return hello. So if I run this again, I have that the value of my function is what is hello now. Right. So we use the return statement only when we wish to do what to return what a value from our function, right? But if we now wish to return a value, then we can do what we can just create a function like that. But I don't think there's any function that we want to create that we do not wish to do what to return a specific value, right? So to do that, we just do this and return that value. So what happens is that I now come here, I check if everything are the same type, add it up and do what and return hello. But this is not what we actually want to return. We want to return what the actual result. So in this case, I'll say return the result of that calculation. And then if we execute this, we should have what the appropriate result being what 15. And then I can use that value and carry out other calculation here. So I can now say, okay, let my final result now be whatever result is being sent from our function being what a add 1,000 to it, right? And then go ahead and show us what our final result. And then if I execute that, we have 1,050. 15 being what the result we got from the function. But then if I try to say, okay, let this be greetings, right? Right. So since the greeting did not have any default value, right? Since the greeting did not have any return statement, so it means that the default value is what is none. And then this will throw an error saying that we cannot add what a non-type. Remember, none too is also a data type in Python. So you can't add none and integer, right? So it means that function did not return anything. This function here did not return any value. So it did what it returned the default value being what none. Right. So I'll put it back as my greetings. Sorry, addition and that. Question. Question. Question.
Please, good evening.
Good evening.
Shadrach, please, I didn't get this return concept you said just now. I didn't get it clearly. Can you? Sorry, I'm taking you back. Can you just go through it again?
You're not taking me back, sir. Yeah, you're right. All right, so let's go over that again. Okay, so we want to use the return statement, okay, when we intend to send out a value or when we intend to change the default value of our function. Okay, I think that's the best explanation, right? So we only want to use the return statement when we intend to alter the default value of a function being what none. Right, so I said that logically, right? If we assign our function invocation to a variable, then of course we can do what we can get a value from that function. So we actually assign this invocation to a variable called a. So before we had that return statement, there was a value that was returned there, right? And that value was none. That is the default value. Oh, I'm still trying to print again. Wait, that. Wait. Okay, so this is happening. So let me comment it out. And let me print this again. All right, so I'll print A again, right? All right, so when I execute this again, right, we have none. So the thing is that there's this default behavior of Python, okay? Now the default behavior of Python is that every function has a value is always returned. So it means that if I assign a function to a variable, I can have what a value, and the default value is always none, right? If I assign my function invocation like I just did to a variable, and then I try to print that variable, I'll have that result they call none, right? That is the default behavior of function, right? there's a specific keyword I'm looking for there, but it's coming and going when it comes to atlas, right? So functions can also be assigned to a variable, right? So function can also hold a value, right? So your function can hold a value, right? And the default value of your function is always none. So it means if I assign my function to a variable, I can have a value, which in this case is what is none, right? Which in this case is what is none. If I run this again, I have what? I have none. So the return statement or the return concept actually comes in. What if you have a specific value that you intend to return and not what? And not none? What if you intend to change that default value of a function, right? So to change that default value, we make use of the keyword none. Sorry, of the keyword of the keyword return. Sorry, memory block. Sorry, we make use of the keyword return, right? Now we use this return inside our function to do what? To return a desired value, right? So I can come inside this my function and say, okay, I want this function here to, okay, after all these conditions are finished, right? I want to return hello, assuming the return now, right, is my default return hello, is my default what is my desired value, right? Assuming I actually intend for hello to be the value that I wish to do was to return. So it means that if I invoke this function, right, and assign it to a variable, I should have what? Hello has a value, right? If I run this now, I should have hello right there as what? As a value of that function. Assuming that is my desired my desired value that I wish that function to do was to actually return. But if I take this off, if I take off this return, that function now goes back to what? To its default value of what? Of none, right?
So in essence, what you are trying to say now is that if we have a function,
okay,
and we write all our plenty code,
okay,
and we put return so value,
okay,
it will leave every code that we have written, all the gbogbo that we have written, and it will go to that return and act on that return, leaving everything. So in preference, it will run return compared to the other codes. Am I getting it right?
Almost. All right. So the thing is that all your code will still execute, right? So it executes all your code here will still execute too, right? So whenever it sees the return, that's where your code ends, right? So the thing then, the return statement is not only used to actually return a specific value. It actually used to terminate your function. So it will execute your code till whenever it sees what the return. Then it knows that function should end there automatically, where they are existing code. Meaning that if I come up here and do what and say return hello, right? It means that you could say that automatically the rest of this code has actually dim in color, right? It means that code can never execute because the return function does not only return a specific value, it also indicates the end of your function. So if I put the return here, right, it means that function is ending there, and also that value should be returned, right? Now if I execute this, you see that nothing actually happens. It still shows our hello, right? But then if I should bring that return out of that place, right, I should bring this man out of here, right? And then I come down here and then I say print the result, right, of this addition. Your code will still execute, right? But then if you don't actually specify your
Please, why printing these results? Can you see remove the return to see whether the return we execute to? Like, can you
I've removed it.
Comment on
okay, all right, of course it will still execute. So if I run this,
the return. Let me just check something.
I've uncommented
like this.
Now if I execute this, right, it executes your code, carry out the instruction, and printed the result of 15. This 15 here is coming from your function that says print what the result, right? But then 15 is not the value of that function. It's only displaying 15 because the function says display the result. But then the original the value of this function now is what is this your hello there, right? That hello there becomes what your value of the function. The 15 that we are seeing here is because we have a print somewhere inside the function. So it's just displaying what 15. But then the return is assigning that value hello to the function. So it means that that function owns the value hello. Every other thing works, but then when you want to get the value of that function, you get hello as the value of the function. That's how the return statement works. So it assigns a value to the function and also terminates that function. So you could say that if I should bring this function right before printing that result, if I should bring the return right before printing that result, you see that print will not have the opportunity to know what to execute. And you could say that let me close this. Let me run this again. So you could say that it showed what the hello. So it assigns a value to the function and also indicate the end of the function. So what happens that when you invoke this function, what happens? Your first instruction will do what? Will execute, saying what? Check if all these are integer, right? If that condition actually matches, right? If all of them are integer, what happens? Go ahead and do what? And can add the addition, right? And assign it to a value called what? To a variable called results, right? Now going on to the next line, it encounters this keyword called return. So what happens? Since return actually works in two ways, assigning what the specified value to the function and also terminating the function. So what happens? It automatically assumes that is the end of your function. So every other code that lives here is gone. It's lost in space, just there. Are you making sense?
Yes, boss. Yes, boss. Yeah.
Any other question? Is there anyone that's finding that?
Thank you very much.
Okay, no problem. Is there anyone? Okay, question.
Please, I'm confused though.
Okay.
The 15 I saw as the results. I don't know how 15 came about.
All right.
I'm
So
just
that's what I'm saying, right? That this result. Okay, let me bring this back here. The 15 we saw there, right? The 15 we saw there was this print keyword, this print statement here. Right now, once you invoke your function, right, of course, every instruction within that function will execute from the first instruction to what all the way to the last instruction. So the first instruction here says what? Check if all the values are of the type of what? Integer, right? Now once you check, once the guy has that check, it does what? If truly, right, that criteria there is being met, do what? Go ahead and add this addition by saying bar 1 plus bar 2 plus bar 3, and then do what? Assign the result of that calculation to what? To a variable called what? This result, right? Now after that, go ahead and do what? And display. Remember, print is what? Print is display what? That result. So that 15 you saw was from that line of code there that displayed that result. But then the 15 is not the value of this function, right? When we don't use the return statement, the function has a default value of none, right? Okay, I'm simply saying now, right? Okay, let's leave the function aspect. Let's come to ourselves, right? I'm simply saying that I believe that all of us here we had the opportunity of having what a naming ceremony, right? Now your default name or your would be what? Would be if I was to address you, right? I will address you as a man, right? Of course you're a man, right? But then since you were actually assigned a name, right? That default addressing of addressing as a man is gone. Now I can simply address you by your name, right? So same thing with that return statement. Once a function actually exists without the return statement, the default value of that function is what is none. But once the return statement is being introduced to that function, the default value of that function becomes the value that is being returned, right?
I don't know if there's this part like if you are from abroad, your first UK address where registered with a GP. I don't understand that.
You're not just a GP, so
Yeah,
you're just
so I don't.
yeah, because obviously that's what
So,
you're
yeah,
trying to do, yeah. So,
Hello, sorry.
Is there a question?
Okay.
Yes.
My issue is if you come to that that's line 21, I think so.
Okay.
The values that are assigned to those variables, I'm just seeing 0, 0, 0, 0. So I'm wondering how the results came to become 15, because by looking at it, it shouldn't come out as 15. That's what I'm saying.
All right, so
Yes,
those
sir.
were the default value. Remember, we said that default values are what are fallback values. Those are like basically values that are being used if the arguments are not provided, right? But in our case, we provided those arguments by saying addition alongside what with those values. So in our case, we provided any values.
Okay. I can understand.
All right.
Excuse me, sir.
Yeah. All right.
Please, and when you invoke the function addition, you assign it to A.
Okay.
And is it possible instead of assigning it to A, because we already have results.
Okay.
Within the definition of the function.
Okay.
So if you continued your result, is it final result is result plus 1,000? Will it fly?
Okay, so okay, to come here and then we say that final result should be result plus 1,000, right?
Without yes.
Okay, so it will not fly, right?
It will not.
Yes. So that was where we intended to talk about function scoping, but we are out of the time already. So function scope, right? But I'll leave that for another class, right? So
okay,
that
so
will
we must do the invocation. We assign it to a variable before we use it at the moment.
At the moment, right? At the moment, to actually have that result, to actually have the value of that result that's inside this function, we can return it, right? By simply coming here to say return that value. We can return it.
Okay,
okay.
Go ahead.
All right. So to actually access a specific value from our function outside the function, right? That's where that return statement comes in. So we're not saying, okay, send out this value of result. So after carrying out this addition there, right? Go ahead and send out this value, right? That's where that return comes in. So that return we send out that value so that we can actually access it like this
with final results.
Exactly.
Okay, thank you.
So at that point, if I say let A be equals to this function invocation, I'm basically saying let A be equals to what? The result. This result. Exactly.
Okay, so once you do the return, you can now go ahead and do that final result without assigning the addition, the invocation.
Exactly. So now once we actually use that return statement, we can now go ahead and say final result should be equals to A. A will have the value of that return statement, right? Because we assign this invocation to what the variable A. So whatever the addition function actually returns will be assigned to this variable called A. Or we can simply just copy it here directly there, right? And just put it there. And that will still work. Some comment, I can take it off. And this will still work. The comment on this, that still works.
Okay. Thank you.
All right. Any other question?
Sir, please, what's the shortcut to indent your code?
Use tab key. Just simply tap it and it will go. Tap this out and that will go. Any other question?
Hello, sir.
Yes.
Hello.
Yeah, I'm hearing you.
Mine is Yes, mine is not really a question, but mine is a question. I really expect this slide should be posted on time. Sometime I really love to go back to all those classes in order to get myself acquainted with these codings, but sometimes it's been posted. Like last class, I did not, I couldn't even practice the last class before this one. So please, they should be helping us post it on time, please.
Okay.
Thank you.
All right, that'll be considered. All right. So guys, so we've overstayed 7 minutes into someone else time. All right. So we wrap it up there. All right. If you have any other question, please do well to leave it on the Discord group, and we will do justice.
You said you have information for us after the class.
Yes. So you guys will go on the group and appoint a rep, an assistant rep. All right. And I'll tell us why we need it in the group. So just go to the group, nominate one male, one female. All right. So just go to the group, nominate someone there, one male and one female. All right. Rep and an assistant rep. And I'll tell us why we need those rep in the group. All right. So let's just do that as soon as we can. Like let's in 30 minutes time, let's have someone, one male and one female. All right. So that's the information. I'll tell us why we need it, right? Why we need it. I'll inform us why we need it. All right. So I'll be expressing that in the group this evening, like now. Okay, like now. All right. So in the absence of any other thing, okay, we'll wrap it up there for today. Next class is live coding again. Please don't miss it. Right. Next class is live coding again. We'll continue from where we stopped in our previous week. In last week, live coding. We continue from there. So don't miss it for any reason. All right. So please do have a fantastic good night rest, and I'll see you guys on Wednesday. Bye.
Thank you, sir.
Thank you, sir.
Thank you.